Okay, I wanted to take a second to just review how to solve equations graphically, because I think a few of you have forgotten what to do for that. So there's a couple of basic ways to do it, and the first one I'm going to show you is the intersection method. So we've got a system of equations here. I'm sorry, we've got just a quadratic equation here. 11x squared minus 3x plus 2 equals 4x plus 1. So to solve this graphically by the intersection method, we're going to sort of set this up as a system of equations. And we're going to take the left side and we're going to set it equal to y1. So we're going to say y1 equals 11x squared minus 3x plus 2. And then for the right side, we're going to set that equal to another equation. We're going to call that y2. So we're going to say y2 is equal to 4x plus 1. Now if you remember solving systems of equations graphically, you graph them basically, and then you look for the point of intersection. Now in this case there's going to be more than one point of intersection. An important thing to keep in mind though is we sort of introduce those y's artificially. We're only looking for the values of x that make this equation true. So let's go to the calculator and enter those values in and see what we get. Okay. So we've got 11x squared minus 3x plus 2. That's y1. And y2 is 4x plus 1. So let's take a look at what they look like in graph. I'm going to go zoom and 6 for standard. And there's our system. There's our system. We've got the quadratic, right, and the linear side. Now this isn't a very good window, so let's change the window a bit. I'm going to use one of the zoom options here, and I'm going to use the first one, Z box. So I press enter, and for Z box what you do is we're going to draw a box around the area we want. So I'm going to press enter, and then I'm going to trace out a box, and what we want to make sure is that this box has the points of intersection. And looking at it, I hope this is going to work. Whoops, I didn't do that right. So zoom box again. So I'm up here, I'm going to press enter for this. I forget to press enter. I'm going to go a little further down than I did last time. And then across. And now I'm going to press enter again. Okay. I might even get a little bit closer. It looks like it hits maybe once or twice. It's really hard to discern, so I'm going to change my zoom again. So I did Z box. I'm going to put one corner here. And I think that's enough. Press enter and see if we can get a better look at how many times it's hitting our graph. Yeah, so now you can see it's hitting our line is hitting our quadratic equation twice, so there should be two solutions for this. Okay, so we've got our graph. Now we want to find those points of intersection. And so for that we're going to go to second, calc, and we're looking for 5, which is intersect. So select 5, and it's going to prompt us. So it's saying, what's the first curve? And up in the corner, you know, the cursor's flashing. It's telling you which graph it's on. It's on the graph of y1, so that's one of our two curves we want. So I'm going to press enter. Then it's going to ask us for the second curve. So it's got y2 equals 4x plus 1. That's the second one we want. I'm going to press enter. And then for the guess, I'm just going to press enter. So it's going to go to the closest one. And there's one of our solutions. So I'm going to capture that. And I'm going to stick it in our thing here. So paste. So there's one of our solutions. And remember, we're only looking at the value for x. The y value is artificial. We introduced that just so we could graph these things. But it's really just this x value. This x is 0.21654,326. And that's not an exact answer. It's an approximation, and the calculator always gives you an approximation. Okay, so there's one value. We have to go back and do it over again to find this second point of intersection, which is up here. So you do second, calc, 5 again. First curve y1, second curve y2. But this time we've got to move our cursor closer to this other point of intersection. Otherwise it'll just go back to the other one. Press enter, and there we go. There's our second solution. X equals that. I'm going to capture this, stick it back in here, paste. I don't know why it compresses those, but it does. So there's our two solutions, our two approximate solutions, right? X equals this value, and x equals this value. So that's one way of graphing it. The other way of graphing it is to set it equal to 0 and then find the x-intercepts. So if we want to set this equal to 0, it's going to be 11x squared minus 7x plus 1. So let's write that down on the next page. It's 11x squared minus 7x plus 1 equals 0. And so in this case, we're just going to graph this as y1, then find the x-intercepts, or the zeros. Okay, so let's go back to the calculator and try that. We're probably going to have to change our window. So we get 11x squared. I'm just going to write over this, minus 7x plus 1. I'm going to clear this one. Let's go to zoom 6, I guess, just to get a look at this. Now again, we've got a pretty tight graph here for this. I'm going to, instead of using the zoom box, I'm just going to zoom in by changing the window. So I want to squeeze it in quite a bit. So maybe I'm going to go from -1 to +2 for x. So -1 to +2. It barely dropped below the x-axis. So for the y-min, I'm going to say maybe -2. And for the y-max, it goes to 10. I'm going to bring it down quite a bit. I'm just going to say to +2. So let's take a look at that graph, see if we can capture. Yeah, I might even zoom in a little bit more. From negative, well, maybe from 0 to 1. and from 1 to positive 1. Let's do that. So x max is 0, y max is 1, y min is negative 1, and y max is 2. And let's graph it now and see what it looks like. Okay. Yeah, we get a clearer view of those. And if you remember, we solved this already. We knew that our values are pretty small. They're less than 1. You know, approximately 0.2 and approximately 0.4 for that. But let's see what happens. So we've graphed it now. And we're going to go back to second. I'm going to clear this. So we're going to go second calc. Whoops, I didn't hit second. I'm going to clear that. It's going to be second calc. And we're going to choose the 0, the second option this time. So we're going to go to 0. Choose that. Now this one, we've got to bracket it between the left and the right. So I'll find this one on the right first. We're a little to the left of that now, down and below that. So I'm going to press enter. Move it so the cursor's to the right of that point. Press enter again. The guess, I'm just going to press enter. It'll find that point, so I'm going to capture that. That's the same value we saw before, 0.41982127. I'm going to paste that in our solution over here. So that's one solution. Go back to Smart View and the calculator emulator and find the next one. So we got to do that all over again. So go second calc, 2 for 0, and we're looking for the left bound. So we have to go get to the left of that point, and this time that's above the graph. So press enter. For the right bound, make sure we're past that point. So this time below that, press enter. For guess, I'm just going to press enter. It'll find that value. There's our second point. And we got the same 2 points each method. So I guess one of the advantages of the first method is if you solve for 0 incorrectly, you know, if you make an addition or subtraction error, you can make an error easily that way. You can avoid that. Anyway, so those are the 2 basic ways for solving an equation graphically. And it doesn't matter what kind of equation. This will work, you know, if you've got radical equations or rational equations or, you know, 5th degree polynomials. This will help you find your solutions, and it's useful for those really difficult equations that can't be solved algebraically. Now this can be solved relatively easily algebraically. You can just use the quadratic formula for this, which is better in the sense that you get an exact answer. But this is a pretty quick way to get an approximate answer for your values.